of x as x approaches c is a real number, or if f of x can be made arbitrarily close to r by taking x sufficiently close to c but not equal to c. If the limit exists and is a real number, then the common notation is limit as x approaches c of f of x equals r. Alright, this sounds very complicated. This is actually the informal definition of a limit. The formal definition is way worse, but thankfully we don't have to look at it. So what I like to do here is draw us a picture of what is happening. Right? So let's make a little XY axis here. We'll just deal with first quadrant just because it's easier to do. And I'm going to call this axis right here x. I'm actually not going to call the y-axis the y-axis. I'm going to call it f of x. Okay. So we have a function here. This function is just some sort of graph. Just draw it like this. It can look any way you want it to look here. And we're looking at the limit of f of x as x approaches c. So x approaches c, your x is getting closer and closer and closer to a c value, so that c needs to go somewhere on our x-axis. And the value of this is a real number r. If r can be made arbitrarily close to r by taking x sufficiently close to c, but not equal to c. So what that looks like, r, so what we're thinking about, a lot of times I'd have you guys when we were doing limits, which you got like a crash course in limits. We didn't, neither semester did I spend enough time on limits, but it's okay because we'll do it in this class. So what we're looking at is as our x value gets closer and closer and closer and closer to c, can be from either side, does our y value, our f of x value, get closer and closer and closer to a value. So right here, as I get closer and closer and closer to c, I can see that that y, or f of x value that goes with it, is this value right over here, right? We approach that same value. That value right there is our capital R. So when we see this limit notation, x approaches c, that c right there, let's highlight some things to kind of correlate them here. This c that we see right here is on our x-axis, right? So we're talking about that x value that you're getting closer to. And then f of x right here, that just means whatever function you're looking at, so that tells you what the graph is. Sometimes it'll be f of x, sometimes it will be the equation that you'll see there. So you'll see x squared plus 7x plus 2. But that was not supposed to turn into a straight line. I was just trying to highlight that. Little pieces at a time so it doesn't auto straighten that out there. Okay, and then the answer to a limit, if you remember whenever we were doing limits, especially graphically, where do our answers to limits come from? Oh, when we're looking at a graph. Always our y, right? So that is our y value that we get closer and closer to. So that sort of lays that out there. So we're mostly, in this section, I just want you to be able to read these off correctly, right? So, so what we're doing for this is I just want you to write out what this means. So we always start off that LIM just tells us the limit of. And then you're taking the limit of something, so it's of whatever is over here. So the limit of x squared plus 7 as this part as x approaches 5. So if we were to write this out, I'm going to type it so you can type it faster. We would say this notation gives us the limit of x squared plus 7 as x approaches 5. Or it's okay if you write it this way, the limit as x approaches 5 of x to the second plus 7. So if you kind of reword it, that's fine. But it's got to be as x approaches, and then it's of whatever your function is there. Okay? So if we see this one has something a little bit weird about it. This one has, let's highlight it here, this. It's got that minus behind our A. Who remembers what that means? From the left, right? So it's not a mistake that I accidentally put the negative behind the number. It means that the limit is from just the left side. So the way that we say that is the limit of g of x as x approaches A from the left. So if we see that negative behind this value that our x is approaching, that means it's only from the left side. If we don't see either one, like we saw over here, it means it's approaching from both sides. You don't have to say from both sides, because it is assumed that if you don't say from the left or from the right, that you mean from both sides. But if you wanted to add from both sides on there, it wouldn't matter. Okay? All right, so for this one, who wants to take a shot at this one? What do you guys think with that plus right there? I know we're going to have the limit of. Okay. Braden, can you finish this one out for me? What's this one going to be? The limit of? Perfect. And again, we've got here that little positive right there tells us that it's from the right. Okay. All right, this one's got a little bit different here. Let's see, Bo, what's this one going to be? Yeah, natural log. You have just said a calculus cuss word. You didn't even know it, but I'm going to have to call them out right now. In calculus, it is a calculus cuss word. And we almost never want to say it in calculus. Because if I see it, I need to know what it is. Right? So when it comes to explaining your work on FRQ questions, if you say it, you have to say what it is. So you pretty much should just altogether avoid saying it. Now, I might do it every once in a while on accident because it's just kind of natural to do. But instead of saying as it approaches infinity, what do you mean whenever you say it? As x approaches infinity. I'm glad that Bo uttered this calculus cuss word so that I can remind you that you're not supposed to say it in calculus. It's like up there with the F word in calculus. Please don't say the F word either, but you could say from the left because it is approaching infinity, but you don't have to. So it would be just kind of understood that it's going to be from the left. But if you said from the left, then that would be fine. If you say from the right, that would make you wrong. Okay. So now what we're going to do is we're going to take the words and go to the limit notation. So given a function f, where f of x equals the square root of x minus 3, find the limit of f of x as x approaches 3 from the right. So we would have limit notation, obviously. And you got two ways you can do this. We know either way we do it, we're going to have an x approaches 3 from the right. So we're going to have to put a little plus sign right there. And because they told us what f of x equals, you can do either the limit as x approaches f of x, or limit of f of x as x approaches 3 from the right. Or you could do the limit as x approaches 3 from the right of the square root of x minus 3. So you could use the function notation for the expression, or you could just use what it actually equals. And for time's sake, I'm going to skip number 6 so we can do the ones that are worded a little differently. 6 is worded basically the same here. It's from the left, so you put negative there. All right, for a function f of x equals x plus 1 over x minus 3, f of x can be made arbitrarily close to 3 by taking x sufficiently close to 5, but not equal to 5. So this is that sort of more complicated wording, but we know we're going to have a limit, and we know we need an x approaches something here. What is x approaching? It's not approaching x plus 1 over x minus 3. So that's not the number that's going to go here. That is what we are taking the limit of. So that could go right here. It's 5. Because it tells us that x sufficiently close to 5. Now, where does 3 go here? We haven't done one with that in it yet. All right, this is your answer. So this is equals 3. So f of x, that's like your y value. So this 3 right here is your y value. That goes as your answer for that one. Okay. And we're out of time. I need to show you what you got to do for homework. So homework is not this. We're going to play a game to kind of practice this a little bit tomorrow. Your homework is going to be to go to Canvas. And right here, homework for tonight is going to be this college credit survey. So if you click on it, it's going to have a link right here that hopefully still takes you to the right place. If you click on that link, you can search. You want to tell it AP Calculus AB. So we're doing AB, not BC. Make sure you pick AP Calculus AB. Then you can search for any college you're interested in going to, and it will tell you what you have to make to get credit there. And so you're going to do at least 3 colleges. You can do more if you want, if you're interested in several. 3 colleges you're interested in going to, and then fill out the Google form. There's like a little Google form that's going to ask you questions about the colleges and what you got to get. Okay, so it is not math related, it's AP related.